Hi everyone, welcome to GTech Techno Solution Private Limited. We are going to discuss about the angles, polygons and circles. This is going to be really fun and interesting. Let us see. The topics that we are going to cover in this session includes the definition for angles, polygons and circle, and further we will be discussing about the angles, polygons, curves, triangle, quadrilateral, circumference, radius, chord, diameter, arc, sector, semicircle and segment. So let us see the definition for angles. Angles are nothing but simple open curves which is made up of only two lines. So here you can see that there are four angles: ABE, EBC, CBD and DBA. So these are the angles that is formed by two lines. An angle can be either an acute angle, a right angle or obtuse or straight angle, or reflex angle and full angle. Next we have polygons. Polygons are nothing but simple closed curves which are made up of more than two lines. So here you can see that these shapes over here are made of more than two lines. You can see pentagon, triangle, square, parallelogram and rectangles, and each of these shapes are made with more than two lines. Hence it is a polygon. Next we have circle. A circle is nothing but a simple closed curve which is formed by a point moving at the same distance from a fixed point. Say, this is your fixed point, and a point which is moving at the same distance from the fixed point is a circle. So it is a closed curve as it is formed by the point which is moving at the same distance. So from the images that is given over here, you have to identify which is the open curve. So you can clearly see that your B image is the odd one out, since it is a closed curve and the rest of the images are open. Hence, they are known as open curves. A, C and B are open curves. Next we have the angle. If there are two rays which are having a common endpoint, then they are said to compose an angle. The two rays are known as the sides or the arms of the angle, and the common endpoint is known as the vertex of the angle. And this distance between the two rays is known as the angle. So here you can clearly see that this ray is an arm and this one is another arm. The point at which the two rays joins is known as the vertex, and this becomes the angle. If you see, the portion that lies in between the two rays is called as the interior angle. So in between the two rays, we have the interior angle. To name an angle, the vertex is always written as the middle letter. So, to name the angle that is formed by the arm P, Q and QR, we have to write the angle with the vertex in between. So this angle is written as PQR or RQP. It emphasizes that your Q, that is your vertex, should be written as the middle letter when you're writing down the angle. Next, we have to find the name of the angle. So the name of this angle over here will be what? So we can denote this angle either as angle O or as angle POQ with O in the center because that's the vertex. Next, we are going to study about the line segments that form the polygon. Your line segments form the polygon are known as the sides of the polygon. Any two sides with the common endpoints, say CB and BA, have the common point as B. So this implies that CB and BA are adjacent sides. The point of intersection of a pair of sides is called as vertex. So, the point of intersection of a pair of sides such as EF and FA is F because that is a vertex and it is a point of intersection. If you see, the end points of the same sides are said to be adjacent vertices. So here, the adjacent vertices in this triangle ABC are AB and BC because the endpoints are on the same side. BC and CA are adjacent. AB and BC are adjacent. So these are the adjacent sides. The line segment joining any two non-adjacent vertices of a polygon. So here you have this to be adjacent vertices because they are nearby to each other. So any line which is obtained by joining non-adjacent vertices of a polygon is said to be diagonal. So here we have two diagonals which is obtained by joining non-adjacent vertices. Next, we have an interesting problem to solve. Look at the figures that is given below. You have to identify the polygon. The answer is A, B and C because these three are mainly made up of line segments, whereas your option D has a curve which is not a line segment. Hence, the first three options are your polygons. Next, we have another interesting question. What are the sides, that is vertices of the polygon A, B, C, D and E? So the sides of the polygon are AB, BC, CD, DE and EA. So these are the sides of the polygon that is given over here. Whereas the vertices are A, B, C, D and E. So these are the vertices of the polygon A, B, C, D and E. Next, we are going to study about the curves. Curves are interesting lines which are drawn without lifting the pencil from the paper. And we do not need a ruler for drawing a curve. A triangle is a polygon which is made up of three line segments. So, there are three line segments in a triangle. Hence, you get the name as triangle, and the triangle has interior and exterior. So this is known as the interior of a triangle, and the exterior is the region that is outside. The line segments that make up this triangle ABC is AB, BC and AC. So these three line segments make up this triangle. Next, we are going to study about the quadrilateral. A quadrilateral is a four-sided polygon. So here, if you see, you have four sides. Any shape that is having four sides is said to be a quadrilateral. And a quadrilateral is named in a cyclic manner. The name of this quadrilateral is A, B, C and D. The quadrilateral has in all four pairs of adjacent sides. The four pairs of adjacent sides include AB, BC, BC and CD as adjacent sides, CD and DA as adjacent sides, DA and AB as adjacent sides. So these are the adjacent sides, and there will be four adjacent sides in a quadrilateral. Your quadrilateral also has two pairs of opposite sides. So if you see, the opposite sides in this quadrilateral are AB and CD, and the other opposite sides are AD and BC. The two nearby angles in a quadrilateral are known as adjacent angles. The adjacent angles over here is A and B. The angles B and C are adjacent. Your angles C and D are adjacent. And your angle D and A are adjacent. So these are the adjacent angles which are nearby in a quadrilateral. Next we are going to study about the circumference of a circle. Circumference is nothing but a line that forms the boundary of a circle. So here we have a circle, and if we find the boundary of the circle, then that is the circumference of the circle. The part which is present inside the circumference of the circle is known as the interior of the circle. In some cases, some points may lie on the circumference of the circle as well. That is over here. Next we are going to see about the radius. Radius is the line segment which joins the center and the point on the circumference. It is denoted by R. So this line segment joins the center of the circle with every point on the circumference. The radius of the circle is half of the diameter. So to find the radius, we have to divide the diameter by half. Suppose if we consider the diameter of a circle is 4, then the radius of the circle will be 2. Next we have an interesting question. Is the diameter double the size of a radius? The answer is yes. The diameter is double the size of the radius. If this portion is your radius, then the diameter is double the times of the radius. So the answer is your diameter is double that of the radius of a circle. Next we are going to study about the chord. A chord is a line segment which joins 2 points that lies on the circle. So a line segment which joins any 2 points on a circle is known as the chord. Next we are going to study about the diameter. A chord that is passing through the center of the circle is known as the diameter. Here, this will be the diameter of the circle C. And you have to note down that your diameter of the circle will be the longest chord of a circle. So the longest possible chord one can draw in a circle will be the diameter of the circle. Next we have arc. An arc is a part of the circumference of the circle. So here if you see, this forms an arc and it is a part of the circumference of a circle. The total circumference of the circle is over here, and this portion over here is the arc. What is a sector? A sector is a part of the circle which is enclosed by two radius. So we have the radius as OA and OB in this circle. And the part of the circle that is enclosed by the two radius is called as the sector. So the colored region over here is the sector of the circle. What is meant by a semicircle? The diameter of a circle divides it into two halves, and each half of the circle is known as semicircle. So the two halves of the circle can be separated and it is known as the semicircle. Next, you have to determine the sector and the segment in a circle. Sector is the region that is formed by joining two radius of a circle. So this region over here is a sector, and the segment is the region of the circle which is obtained by the chord that is drawn in a circle. A chord is a line segment that joins any 2 points in a circle. So the region formed by a chord is known as segment, and the region that is formed by joining the two radius of a circle is known as the sector. Next, we are going to study about the segment. Your segment is a part of a circle that is enclosed by the chord, and the arc is called as the segment of the circle. So here we have a chord PQ, and the arc is X. So the part of the circle over here is known as the segment, and we can differentiate this as minor segment and major segment. The minor segment is the region bound by the chord and the minor arc. Here the minor arc is X, and this becomes the minor segment. P, X and Q becomes the minor segment, whereas your P, Y and Q becomes the major segment as it is the major arc. So this is all about segment. Thank you so much for joining GTech. Hope you would have studied a lot about the polygons, chords and segments. Thank you.